Over section 2 of chapter 1 in geometry. Your objectives in this section are to use symbols, find distances, and use postulates involving segments. So we need to define a few things. I'm going to go ahead and type these in so you can read them a little bit better than my normal handwriting. But a segment is a part of a line having two endpoints. A ray is part of a line having one endpoint and extending forever in one direction. And then finally, opposite rays. You have two rays with a common endpoint that together form a line. Oops. Form a line. There we go. So, got those in your notes, but you can also draw something to go with that if necessary. So I'm trying to mark up here. If I have an example, I could have a segment, right? DJ, if I just put a line over the top of DJ, I mean I'm going from D to J, and I'm just talking about this segment of my line, this line that extends forever in both directions, right? But if I'm just talking about this chunk from here to here, then I'm going to talk about line segment DJ. Whereas a ray, DJ, would look more like this. If I have an arrow over the top of that DJ, I'm starting from D, going towards J forever in that direction. So if I switch my color here real quick, I could start from D, if that worked, go towards J, but go forever in this direction. That would be a ray. Right, so it's just part of that line, the part that's extending to get forever towards the right, but there's also that other part of the line that goes forever to the left. And that red ray that I just drew could have an opposite ray that I'll make green here that's opposite of it, and together those two rays, the green and the red, form a line. So just some definitions we need to know. But we also have a length. We need to define congruent and midpoint. So I'll type in some things for those as well. I'm going to switch my cursor here. Oh, what do I need to do to get in there? It won't let me. There we go. So we got length here, how long a segment is. Congruent means equal in measure. Midpoint is a point that divides a segment in two congruent parts. Point that divides a segment into two congruent parts. All right? So again, you get the idea. I kind of lost my parts. Must be down below if I scroll a little bit here. Can't see what's going on. Wants to fight with me, this screen. Anyway. So length. Again, how long a segment is. I could have this line segment AD here. So connect the dots. A has a coordinate in a number line of 9 and D is 14. When I ask what is the length of AD, well, AD, oops, wrong letter first, AD equals 5, right? There's 5 units between 9 and 14. That's what it would look like if I was asked for a length. I don't put a line over the top of this, but it is referring to line segment AD, and it has a length of 5. Congruent, equal in measure. I have a symbol that means congruent that you use. It's an equal sign with a little squiggly line on top like this. You need to know that that means congruent, because a lot of times in notes I won't say congruent. I'll use that symbol, and you'll need to know what that means. So when you see that symbol, it means congruent, and a midpoint divides a segment into 2 congruent parts. So we had trouble with that when we did our pretest, because you guys understood that, okay, the midpoint would be in the middle here, right? But unless I can tell that that's actually the midpoint, unless you tell me that, okay, I have this line AD again, and this point B in the middle is my midpoint, the only way I would know that is if I could see the coordinates and just determine that that's the midpoint, or possibly use some marks like a little hash here and a hash here that means that those 2 segments are congruent. I'll put those in figures at some point or another. So I need to know that those 2 segments are congruent some way, somehow, but that midpoint B is right in the middle of A and D. So then I have segment bisector. So I need to switch back here so I can type that out. Segment bisector is something that goes through the midpoint of a segment. Ruler postulate. Right, you got a little bit more space here than I gave, but there's 2 different parts to this ruler postulate. The first thing, subtract endpoints to find length. Did not know that I just did that in caps lock. That's interesting, but that's fine. Leave it. 2, probably pretty important, so it can stay in caps lock. But otherwise, any point, any point can be assigned as 0. So you need to know how to find a length, and that's your ruler postulate. Any point can be assigned 0. Segment addition postulate. Sometimes I'll just say segment addition like that in symbol form. But if B is between A and C, then AB plus BC equals AC. Excuse me, keep missing. So let's work with those things a little bit. First with that ruler postulate. Again, this goes back to that example I had before, possibly. So when I had that length, when I was trying to figure out how far away A was from D, and I had 2 points that had coordinates of 9 and 14, I subtract those 2 things, that gives me my length. What I need to know, though, is that that length will always be positive, because I might not have numbers like 9 and 14, right? And it depends on how I want to do it. I can take 14 and subtract 9 and I can get 5. Or I can take 9 and subtract 14. I just need to understand that that negative 5 isn't my real answer, it's the absolute value of that answer that I'm concerned with. So when you see worksheet versions of this, right, I can also be in that negative portion of my number line. So I can have a negative 5 over here and a negative 3, and I want to know how long this is. I can take a negative 5 and subtract a negative 3. So I'm really going to add that 3 to the negative 5, and I'm going to end up with a negative 2, which is not my answer because I want a positive answer. It's just 2, right? But obviously, if you took a negative 3 and subtracted a negative 5 from it, that would actually give you the positive 2 that you wanted from the beginning. So it just depends on what you're looking at. But subtract those endpoints to find the length. Just remember that it's always a positive answer. It's the absolute value of that answer that we really want. Otherwise, any point can be assigned as 0. So this A could have easily been 0, but D would then be 5, right? So I can move 0 around, do whatever I need to do, but when it's all said and done, subtract 2 points to find the length. Segment addition postulate just tells me that, okay, I have a line here that has 3 points in it, A, B, and C. And all Euler postulate tells me is that this segment AB plus BC is equal to AC, which should be pretty obvious when you look at that, but definitely something we needed to define so that we can use that going forward. So those 2 parts make up the whole. Oop, one last thing. I was missing something in my slide here. So before we move on, there's also one other thing I want to add in there. If you want to find a midpoint, undo that. You're going to add endpoints and divide by 2. So add endpoints and then divide by 2. So if, again, I had A and B on this line, this segment, and I want to find the midpoint of A and B, that's 4, this is 14. I'm going to take 4 and I'm going to add 14 to it, divide that by 2. 4 plus 14 is 18, divided by 2 is 9. So that means that the coordinate of my midpoint is going to be a 9, which is 5 away from 4, and it's also 5 away from 14. Again, using Euler postulate, I'm just subtracting those things. But this midpoint X is 5 away from both A and B, right? A bisector could be passing through X, so I could have a line going through here, and that's another thing we talked about that I didn't show in a picture yet. But all of these things kind of go together, and you have some examples that you need to work through on the right half of your notes. So try and answer these things first, right, just like we did last time. Pause the video so that you can answer those things, and then go ahead and restart it because I'm going to go through those answers right now. So if I'm trying to find the midpoint of DJ, so D is right here, J is over here, right? Visually, I can already see that G is probably going to be my midpoint. But again, to do that, I'm supposed to add my endpoints, -2 plus 4, and divide by 2. So -2 plus 4 is a +2, divided by 2 is 1, and 1 is the coordinate of G, so my midpoint is G. BH, remember when I don't put a line above it, I'm just asking you for the length of said segment. So B is over here at -4, H is over here at 2. If I subtract those two numbers according to my Euler postulate, I should be able to get my length, right? So it's 2 minus a -4. That means I'm going to have a 6. BH is 6. Again, you can visually see that. You can even count on your number line 1, 2, 3, 4, 5, 6 over from B to H. But we're trying to use those rules to our advantage and learn how to use them. M is the midpoint of AB. So I have this diagram over here. AM is congruent to MB. That's what midpoint is telling me right now. So if I am given 4x plus 3 is AM, and 5x minus 2 is MB, I should be able to find out what x is, because those things are congruent. 4x plus 3 equals 5x minus 2. So then I just subtract that 4x across. That leaves me just x on the right side. I add that 2 over here. X equals 5, right? I can check my work if I want to. 4 times 5 is 20, so that's 23 for AM. 5 times 5 is 25, minus 2 is 23 also for MB, so those are definitely congruent. If GM equals 3x plus 2 and MH equals 4x plus 8 and GH is 38, then x equals what, right? So this part of my diagram, GH, right, M is not the midpoint of GH. So all I'm going to think about here is that I know that this portion of the line plus this portion of the line, MH, GM plus MH is equal to GH as a whole. So 3x plus 2 is my GM plus 4x plus 8, that's my MH, is equal to 38. The total should be that GH segment. So I just work this out. 7x plus 10 equals 38. That means that 7x equals 28. X equals 4 when I divide by 7. So I can plug that in, get 4. 3 times 4 is 12 plus 2. I know that GM is 14. 4 times 4 is 16 plus 8 is 24. 24 plus 14 is equal to 38. So I know that I did that right. I can check. Now notice that the picture doesn't necessarily make sense in that case, because 14 is smaller than 24. But that's something you need to learn in geometry. Don't fall in love with the picture. I didn't intend to make it to scale every time, right? So you're not always going to see things work out nicely like what just happened there. Don't worry about it too much. I can't make them perfectly to scale every time. So then finally, I just need to draw PQ and MN so that MN bisects PQ, but PQ doesn't bisect MN. So that's actually very similar to the last picture that we just had. So I have this line that's PQ, and it is being bisected. So I want to know kind of a midpoint here, right? And then I'm going to go through that midpoint, but I'm going to try and make it obvious that this segment of that line is shorter than this segment of the line, so that I have MN here. Oops, didn't mean to put the MNN there. I have MN that is bisecting PQ. These two segments are congruent. I could put a mark in there to show that it's congruent. Right? If I already used one mark on one part of my diagram, I might put 2 marks on both segments to indicate that they're congruent. But PQ is bisected, MN is not. So this would be a good picture. All right, so that's all of your notes for section 2. Just try and do that worksheet.